Thanks everyone for coming to this. So we're going to be doing a gentle introduction to Scala with the Scala Koans. And to talk a little bit about what exactly Koans are, I'm just going to put up the dictionary definition here, which is a paradoxical anecdote or riddle used in Zen Buddhism to demonstrate the inadequacy of logical reasoning and to provoke enlightenment. We are not going to get this deep. At least I hope we don't. It's going to get weird if we do. The basic idea of a Koans is, at least in this context, to provide a little program that we need to make pass. So it's going to have some pieces that are missing. It's going to have a part that we need to fill in. And the goal for this is to just have a kind of discussion with you guys, and hopefully have you guys participate to help me fill in the little pieces that are missing and hopefully learn Scala along the way. So we're going to start with some super basic language features and work our way up through this and kind of go through it and hopefully have a fun interactive programming exercise. So I do have a couple links up here for following along. What I will say is that the original Scala Koans was written in about 2010 and hasn't been touched since 2014. So the original link is here, scalakoans.webfactional.com. You can go there and just download the link if you want to follow along with the code. That will not work with the versions of SBT you guys have installed today because it just, like I said, has not been maintained. So if you want to have something that will run in IntelliJ that you have installed, github.com/mattfowler/scalakoans. Basically, I updated it to work with the latest versions of Scala. So does anyone have any questions about Scala Koans in general? All right. So we can go ahead and get started. So the first one that we'll do here is kind of just a gentle introduction to how exactly Scala Koans work. So the whole point here is that we'll have a bunch of different tests here, and basically this one here is just the first Koan, and basically we'll have a Koan and then a little bit of text that describes what exactly we're doing, and then the actual test itself here. And then what we're going to do is we're going to run this, and we're basically going to see all these tests fail and give us an error. And then our job is going to be to take that, fill it out, and get it to pass. So these first ones are really simple and are really just about how the Koans work in general. So our first Koan is, and can everyone see my screen okay? Okay, great. So the first Koan is assert can take a Boolean argument. So what we're doing here is basically all we're going to be doing is asserting some facts. So basically trying to check and see if certain things evaluate to true. In that case, we're going to the test is going to pass and we're going to move on. So this first one is super simple. So we have an assert statement. Right now we're asserting false. Yep. Let's do that. Is that better? You want some more? That's good? All right. Yeah, I'll scream. All right, so this is our first one. If I run this, you can see here, we've actually failed. So basically what this is saying is test failed, exception was thrown. So basically it's telling us that we're not passing. So basically here we see assert false, and assert is only going to let it pass if we return true, essentially. So what should I change false to get this to pass? True. Sounds good to me. So let's run this and see if we can get this to pass. Awesome. So if we see this little green thing down here, that means we passed. So you guys wrote your first passing Scala test. So the other nice thing about these assertions is that I can include a message if I want to kind of convey some sort of message about what the actual failure is. So this one here, as you can see here, I've got this little exception down here that says this should be true. So what should I change this to be? Awesome. You guys are getting the hang of this quick. Awesome. So we got our first two. So the other way we can do assertions here is with what's called a should matcher. So we basically have this syntax that allows us to say something should be true instead of just doing an assert. And one of the things you'll notice here is we have these underscores here. So as we're going through these, you'll see some of these underscores here, which is a key to us that we're going to need to fill in a value to make the actual test pass. So what should true be? True should be awesome. I could type. on this and see that our little program passes. Right. So now here we just want to do a simple equality check. So this is another way we can make an assertion. So right here you'll see I have this triple equal. This is the same thing as the assert we saw above, but it's from Scala test, which is the actual library we're using to actually run the unit tests. So basically we can say something triple equals something. So here what we're trying to do is we're trying to say, v1, what is it equal to here? What do we want to fill in this little underscore arrow here to make this pass? v2, awesome. Nice. So now we also have down here, we can just assert some things that are equal. So this is kind of just a rehash of the above ones where we have this little arrow here where we want to fill something in. So what does this expression evaluate to? 2. Awesome. And then I think all of our about asserts tests are passing, and we've done our first one. So kind of a general introduction here to what these tests are all going to be about and what we're going to be doing here. Any questions on this? All right. So we're going to move on to var and val. About val and var. So when you're defining a variable in Scala, you have two things you can do. So you can create a var, which is a variable, or you can create a val, which is a value. The point of a var is a var can change. A val can never change. It remains constant. So basically what we're doing here is we're creating a var a. We're setting it equal to 5. And then we're saying a should be 10. And you can see here, if I run this, we'll actually have a test failure up here. And we'll say 5 was not equal to 10. So what should we do here to get this to pass? 5. So we'll get that to pass, but then what we can do here with a var is notice that we can actually change the value after the fact. So if we set it to 7, what should we have here? Awesome. 7. Okay, so our next one is vals or values which may not be reassigned, analogous to final in Java. So by show of hands, who here has some Java experience? Awesome, so you guys all know final. Final basically means we cannot change the value once we've created it. So I'll just do this here, just since we know that 5 should be 5 if we've assigned it. But the question here for you guys is what happens if we comment these lines here now that we know that val can't be reassigned? Error. So let's see what happens when we run this. So yeah, we don't even need to run it because IntelliJ is going to start screaming at us that you're trying to reassign something you can't. So we'll leave this guy alone. Okay, so something you'd notice up here that I was doing is this is kind of, this is obviously an integer, but we didn't actually say on this is an integer. So one of the things we can do is, types are inferred by default, which means the Scala compiler will automatically figure out what type things are based on what you pass in there. But what you can do here is you can use this colon syntax to say, hey, var b, this is actually a string, and I want to, save it as a string. So we can actually explicitly add that in there. And then right here, we're going to test out some string concatenation. So basically, what should we be changing this to be to get this test to pass? So we're taking b, which is a string, we're adding a space, and then we're adding the number 10 to it. Any ideas? Huh? Hello space 10. Let's give that a shot. Great.
Why didn't you have to do like a convert none to string?
That's a good question. So it's actually going to do an automatic conversion here for you.
Okay.
It's kind of, I think there's something in Scala called implicits, where it kind of will do those conversions for you, and I believe that's what this is using, something called implicits. We probably won't get into that today, but that is, I believe, how that's happening. Okay. This one's a little easy, but we'll just talk about it. So basically, if you want to name your variables something kind of crazy, you can use this backtick syntax, which will give you, a way to actually write a very descriptive variable name. So what we're doing here is we're just referencing that and adding 30 to it. So what should our value here be? 530. Great. I'm going to skip over this one because it's pretty much the same thing as we did before there, but you can also, this one's a little funny one, but backticks can also be used to spite your coworkers and send them into a spiral of confusion and agony. So what we are doing here is we're actually using the backtick syntax to actually define variables that are named actually reserved keywords within Scala. So a reserved keyword is going to be something like false, return, true. So what we're doing here is we're defining void to be 100, false to be true, and return to be 90. So this one's a little bit of a brain bender, but if false, void, else return should be. So what do we think should happen here, given that false is true, void is 100, so it should be 100? 100. Awesome, we got it. So I guess it wasn't that confusing. But don't do that to your coworkers, it's really rude. All right, so this next one is about lazy vowels. And lazy vowels are one of the cool features of Scala that you can get that aren't really in any other language as far as I'm aware of. So lazy vowel is an assignment that will not be evaluated until it is called. So what that means is that I can define a variable and basically have a block of code here not get evaluated until I actually reference that variable. So the thing to note about here is whenever I define this here, I'm actually eagerly evaluating that. So let's say that I'm writing some complicated code and I have a long-running operation. And maybe I'm going to use that long-running operation, maybe I'm not. The problem with doing it with just a plain val is that every time that I hit this code, I'm actually going to run that long-running computation. And maybe I don't necessarily want to do that. So one of the ways you can avoid that is by using a lazy val. So a lazy val is actually going to only be used and computed when I actually start using that variable. The interesting thing to note about this as well is it's actually going to cache the variable. So let's say I have this really expensive algorithm that I'm running, and it's only going to ever return the same value once I compute it. I can then actually save that value and save myself from having to compute it over and over again. So what we've defined here is lazy val a. We have a var up here, so this value can change. We set history equal to history plus 5, and then we return 19. So what should history be right after this line here? What's that? 5? Should be blank, right, because we haven't executed anything yet. Okay. Now we do A. What should A be now?
So return isn't returning 19?
19, yeah, because this is the last value here, right? So we've now computed this. So 19. Okay, and what should history be now? 5. Now it should be 5. All right, let's see if we got that. We got it, nice. All right, so any questions on val and var? Yes.
I just showed up. I'm sorry. I saw should be. Is that part of unit testing in Scala, or is that something?
Yeah, so that's actually part of Scala test, which is the library that we've pulled in as part of this. So basically that's actually a dependency. It's not part of the Scala language itself. But yeah, basically Scala test is pretty much the de facto unit testing framework within Scala. you can use other ones, but Scala test is by far the most popular. So, yep.
Also kind of getting kind of used to having methods as space, like have an object space.
Yeah.
So with that, like have an object, an evaluation, an expression evaluated should be, say, 10.
Yes.
Like, what do you think is happening between the object should and be? Is should be the method, or?
Yeah, I believe should be is actually the method. It's like should. I think if you can actually write it should.be. I'm unsure of the actual way that it's getting called, but if you were to poke into the syntax here, let's see. You can do that. I believe we'll see it'll go, and you'll see that it's actually a val and it's actually a class. It's somewhat complicated. I think then you're getting to the internals of how this is. I don't think I'd be able to explain that to you right now.
Adopt that and say not.
Yes. Yeah, you could do not be. Yep. All right. So let's move on to the next one, which is about classes. All right, so like any good object-oriented programmers, so you guys, some of you have experience with Java, we want to be able to create classes to actually house abstractions within our programs. So you can define classes here with var or val parameters. So I've defined a class with a var parameter here. It's var description, and it's just a string. And I've defined a class with a val parameter here, and it's got just a name. And these next couple tests, we're going to see kind of what the difference between declaring something with var versus val makes. So a val parameter in a class definition defines a getter. Essentially, that's basically it. So basically, I'm going to take this class that we have defined up here, and I'm going to create a new instance of it. I'm going to say new class with val parameter. I'm going to pass it in the description of names go here. So once I've done that, defining it with val, that basically would define a getter, so I can always get that value out with actually having to write any sort of boilerplate. So a class.name, I can just reference it that. So what should the value here be? Name goes here. Let's run this and see if we get that guy to pass. Awesome. So var parameters in class definition define both a getter and a setter. So this one only provided us with a getter because remember, like when we use val, we're defining something that can't be changed. So we in effect say, I'm always just going to get this value and that's it. I can never ever reassign it. So var parameters in class definitions define a getter and setter. So pretty much the same thing as above. So class with var parameter, description goes here. So we can just copy our original one here because we've just defined it. So that's going to be description goes here. And now what we're going to do is we're actually going to reassign that. So we're going to say aclass.description equals new description. So basically have reassigned that particular class variable of description. So what should we be down here? New description. Awesome. So this one is actually just kind of a note, and it's already a passing test, but what happens if we don't define var or val? So we basically here have class with private fields. So we just say name, defined as a string, and note that we don't pass val or var in here. And what this is going to do is it's actually going to hide that data from everyone. So basically one of the things here is if we create this, and then just go here, aclass.name, you'll notice that I can't even access that. So that's just basically defining a private variable for us that external callers can never ever see. All right, so does anyone have any questions on classes? Okay. All right, so we'll talk a little bit about ranges now. And that's going to be interesting for some of the stuff that comes up later in these exercises. All right, so Scala allows you to kind of generate ranges of numbers very easily. So one of the things that we're going to do here is kind of generate a range from 0 to 10. The thing to note about generating a range is ranges are not inclusive until the end of the range. So basically what we're doing here is we're just saying some numbers from 0 to 10. And what we want to do is we want to basically check and see what the size of that is after we create it. So bear in mind that it says up here we're not inclusive to the end of the range. So 0 to 10, not inclusive to the end. Thinking about what the size of that should be. So if we create a range 0 to 10, not inclusive, how many numbers are going to be in it? I heard, well, let's try. So I heard 10 first. So let's see what happens.
If it's not,
So we got 10, because essentially we're going to go 0 to 9, and that's going to include 0. So 0 through 9 is going to be, you're going to have that extra number right at the front, so you're going to get 10.
so that's just range by definition, not because of the parentheses.
Right, it's always going to be parentheses,
All right,
but yeah,
I
that's
was
the,
thinking
yep.
mathematically, I was like, yep, okay.
Yeah, you can't do like, yeah,
Oh, right.
that's going to give you an error.
Okay.
All right, range can define a step for an increment. So this is actually going to be, when we did it before, we did 0 to 10, and that's an implicit increment of just 1. So, 0, 1, 2, 3, 4, up to 9. But here we can actually define a step. So this is kind of hard to see, but this is actually my starting value. This is my ending value, which is going to be 10, much the same way. And my increment here is going to be 3. So I'm going to be starting at 2, I'm going to be incrementing by 3, and I'm going to go all the way up to 10, not inclusive. So how many numbers are going to be in this set? 3. Nice. Okay, so next one just is kind of reiterating the fact that range does not include the last item, even if you give a step increment. So here we're going to start at 0, we're going to go up to 34, and we're going to go by 2. So 0, 2, 4, up to there. So some numbers contains 33. So should we have 33 here? No. Should we have 32? What about 34? No. Awesome. So now, by default, this does not include the last value, but we can very explicitly say, do include the last value. So range 0 to 34, so again, numbers from 0 to 34, but at the end we just say dot inclusive. So some numbers contains 34. What should this be in this case? True. Awesome. So we've learned about ranges in Scala. So let's move on to tuples, which is one of the things that is we're starting to get into the fun Scala features now.
Question.
Yes.
Does a range compute lazily?
That's a really good
Is
question.
that why you're able to call inclusive after having the expression?
I do not know the answer of that. I would actually assume that they're eager. There are something in Scala called streams, which kind of allow you to find those lazily, and you can actually compute infinite lists with them. But I actually think that, does anyone know? Are they evaluated eagerly? They are? Yeah, that's what I thought. I'm actually pretty sure. A little anecdote, I was actually working on a project that involved wearable biometric sensors, and we had to do ranges because I thought it would be a nice abstraction, but then I actually wound up blowing up the application because I ran out of memory. So yes, they are generated eagerly. Okay, so tuples are one of the things in Scala that allows us to kind of group a couple of data elements together. So tuples are created easily, and basically all it is you have this parentheses syntax. And then what that'll do is it'll kind of group apple and dog together into one little logical object. So this one's pretty simple. I'm just going to do this one, but because basically all it wants us to do here is apple and dog will be apple and dog. Basically just defining a tuple. And then we'll kind of see actually how to use a tuple and what it could potentially be good for. So tuple items may be accessed individually. So we've defined a little tuple here that has apple and dog, just two little strings, but how do we actually utilize those values? So Scala has this syntax that's _1 and _2. So what we're doing here is we're saying, from this tuple, grab me the first element in that tuple. What we're doing here is we're saying, grab me the second element in that tuple. So what fruit should we be getting out here?
Apple.
Apple. Right, first element of that tuple. What about animal? Dog. Awesome. So, the interesting thing to note about tuples is that they can have mixed types. So if you go up here, we're kind of defining two things that are just strings, right? So if I go and actually add the type, because we explicitly do that, you can see that this is a tuple of string to string. But that doesn't necessarily limit us to just defining things of one type. So we can actually add all sorts of different things here. So we've got a string, we've got an integer, we've got a floating point, we've got an actual data object, and we've got a big decimal. And the interesting thing to notice about tuples is I can have like pretty much as many fields in here as I want, and it's going to be incrementing that underscore index syntax so I can access individual values. So we've got this tuple with 5 elements in it. So what's the second element there that I should be able to get out with tuple _5? Sorry. The big decimal?
Or
_2. _2. 1.
Oh.
Right, the second element of the tuple. 1. Yep. I'm sorry, I didn't hear that.
Is there a reason the tuple of 1 index and 0 index?
That's a good question. Yeah, I don't have an answer for that. I'd have to look at the Scala language spec and maybe ask Martin Odersky for that one. All right. So what about the fifth element? Big decimal. Big decimal of 5. All right. So tuple items can be swapped on a tuple 2. So what we have up here is actually a tuple 5, but when we have a tuple 2 and we want to get fancy, we want to swap it, we can actually swap those values kind of in place with the swap function. So I have a tuple here that's apple and 3, but I don't like the ordering of that, so I want to kind of switch them around. So I call the swap function, and now I flipped the 3 to the first element, and I flipped apple to 2. So after I call this swap, what's the first element of my tuple? 3. What's the second? Apple. Awesome. So I will say this about tuples. One of the things that gets kind of clunky about tuples when you're developing, kind of have this kind of syntax up here where it's like, okay, what is, I've got a string, I've got an integer, I've got a double. The problem with tuples when you're like writing code is that tuple _5 is very nondescript as to what's going on in your code. So generally speaking, if you're trying to write stuff and you kind of see stuff like this, it's probably a smell that you probably want to actually use a class or an object because, the people who are reading the code after you and wondering what tuple 5 is are probably going to be really confused. There's lists and arrays, and I think lists are actually next. Tuples are kind of this weird, it's actually a separate data structure within Scala. It's not really a list or it's actually its own class. Yeah. So at least in Scala, you can have as many as you want. I think previously, I think it's as many as you want now. I think older versions of Scala actually limited it to like 22 or something like that. But yeah, generally speaking, like you would not see this very often in most Scala code. You generally only see it used as pairs. That's probably the more common use of it.
I think too, also in Python, the only Python is that you use utility.
Yeah. Yes.
What was 2.5? Like the decimal? Should I take this one?
1, 2, 3, 4, 5. It's one based.
That's not, it's one of these.
Yeah, it's one based.
So what happens if you have an odd number of elements in each one of the
Well, we can try doing that right here. Let's see what happens. I actually don't know. I suspect the method's not even on there. Yeah, the method's not even on there. Yeah, the reason being, and I believe, is because, like you're saying, like it's actually like a pair is like kind of a separate. So I believe actually under the hood, there's actually separate data structures for each of these. So instead of like it being like this is nice fancy syntax, but this actually converts into something called a tuple 5, separate class. This is just a tuple 2, which they're all separate classes. All right, any more questions on tuples?
I heard mutability. Right?
Yeah. Yep. All right. So now we're going to get into lists. This is where we're going to see some more interesting stuff. Just do a quick time check here. All right, we'll get through what we can in here, and then we'll kind of move on to the next one. This one's a bit bigger. So these two are about kind of identity and equality and what is and what isn't something, which maybe we will get a little philosophical now that I think about it. So we have two ways of testing equality. So we can check to see if something's the same object, the exact same object, or maybe it's not the same object, but it has the same elements inside of it. So here's how we kind of create a list in Scala. So it's quite simple. You just say list of, and then just define the elements. So we have two lists here. List 1, 2, and 3, and we have another list 1, 2, and 3. We're creating two different lists that have the exact same contents. Now we have this EQ, which tests identity, whether it's the same object. So the question here is, if I do A, EQ, B, are these the same objects, or are they not? False. Right, because I create two different objects, and they're both different places actually in memory. Awesome. So now we're going to talk about double equals, which double equals tests equality, which is the same content. So again, I'm doing the same thing, creating two lists with the exact same content. So if I call double equals here, what should I have? True. Yeah, so for those of you who are in the Java land, this is actually quite a bit different because it's actually exactly the opposite from the way Java does it. So that's always fun. Okay, so one of the ways that Scala handles lists is by dealing with kind of what's called a nil terminator. So essentially, every list in Scala is going to kind of end in nil. And the thing about nil is it's actually kind of an object that's shared amongst everyone, and it doesn't really have a type associated with it. So what we're talking about here is nil lists. So nil lists are identical, even if different types. So basically what I'm defining here is two essentially lists with nothing in it. So I create a list here of string and just say, that's an empty list. I create a list of integer here. No, it's an empty list too. So kind of thinking about what we just learned about equality and value checks, what are we expecting A equals nil to be here? True. What about, does it equal nil? True. Yep. Now what about B? Is that going to be the same? Are these both going to be the same? Yeah. Are the references going to be the same? True. Now what about these two lists? We have a list of string and a list of int. Are they going to be equal?
Same values
The same values, right? They're both nil. What about the equality? Both the same? True? True. I hear true. Let's see if we got this one. No, lists are identical, even of different types. Nice. It's an easy one. All right, lists are easily created. We just saw how to create lists. I'm going to move over this one. Lists can be accessed via head and tail. So this is one of the nice convenience methods that exists on Scala lists. If I want to get the first or the last element of the list, I can get the first element of the list with head. Actually, I should say tail is not actually the last element. Tail is actually the rest of the list. So basically what I can do here is head is going to get the single element that is the first of the list, and tail is everything after the first element. So if I do a.head, what should I have here from this list of 1, 2, and 3? 1. What about a.tail? What's that going to be? 2 and 3. So the rest of the list, right? Awesome. So we can access lists by position. So that's just basically saying that I can index it as if it were an array. So I have a list of 1, 3, 5, 7, and 9 here. And I basically want to just extract elements out of here. So this is actually a little bit different from tuple in that we're actually zero-based now. So I want to get A0, A2, and A4. So what should my first element here be? 1. What about my third element? 5. What about my fourth, or actually fifth element? 9. Let's see what happens here, because I think this one's actually going to now. So the interesting thing that's going to happen here is that you can see here we have this intercept index out of bounds exception. So those of you who are familiar with Java are going to have seen this before. But basically, if I try and access the fifth element here, we're actually going to get an index out of bounds exception. It's going to complain at us because we do type check. We do check that. So that's not going to print. Oh well. Okay. So lists are immutable. So I think this one's a little bit poorly named, but this is where we're actually going to get into some functional programming type stuff where we're actually going to be removing elements from the list. So I have a list here of 1, 3, 5, 7, and 9. And I want to remove everything that's equal to 5. Now, in most languages, you would write some sort of for loop to actually loop through that, check and see if it's 5, and create a new list. But with Scala, I can do something called filtering. And what I can do here is I can actually say a.filterNot, and then essentially here, I'm passing in an anonymous function. And basically, what this is going to do is actually good for each element in this list. It's actually going to run this check. And then if it passes that check, it's actually going to remove that element from a list. And what I'm actually doing here is I'm generating an entirely new list where everything in that new list doesn't match this predicate. So basically we have an assertion here that says, once I create this list, it should equal itself, which obviously we're there. But let's say that I run this filter operation on it. I'm generating a new list B with everything that's 5 removed here. So what should I have now? 1379. All right, so it's time check. Okay, so I'll go over this next one. And then we'll kind of have a few questions, and then we'll kind of finish up at 1 o'clock and let Mark give his talk. All right, so lists have many useful methods. So basically, we're just going to we'll run through a few of the interesting methods on list, and I think down here you'll see some more interesting ones that are kind of getting more into the functional aspects of what Scala can do. So I have a list of 1, 3, 5, 7, and 9, and I want to get the length of that list. So obviously a.length should equal what? 5. All right, and now this is the common interview question, and this is actually the correct answer to that interview question. How do you reverse a list? A.reverse. So what should my list be now that I've reversed it? Right. 9, 7, 5, 3, 1. Awesome. So I'm going to skip over this one because it's just a string method to kind of generate that. That's not super interesting, but talk a little bit about kind of map and filter. So we already saw filter not, which is pretty much the same thing as filter, but one of the things we can do here is you'll notice this syntax is slightly different from what we had before. One of the things that lists let you do is kind of map over them. And essentially, like I mentioned before, like in normal languages, if I wanted to kind of multiply every element in the list by 2, I'd write a for loop, I'd loop over it, I'd create a new list with those new elements in it. In Scala, I don't have to do that. That's just a one-line operation for me. So what map does is it takes in this, again, this anonymous function syntax here and says, for every element in this list, I'm going to apply this function to it. So what I'm doing here is I'm saying list 1, take a list of 1, take the first element, multiply it by 2. Up here, I'm going to take 3, multiply it by 2, 5, multiply by 2, 7 by 2, 9 by 2, and generate a new list of those elements without actually having to do any loops. So basically here, I'm taking everything, multiplying by 2. So what should I have in this list now that I've generated a new list by doubling everything by 2? 2, 6, 10, 14, 18. Nice. All right. So filter any values divisible by 3 in the list. So same thing here. So what I'm going to be doing is using this filter function. And again, I'm passing in a function, anonymous function value here, saying for each element in this, run this check, and if it matches that, add it to the list. So basically, v modulus 3 equals 0, so that's checking divisibility by 3. So I'm going to be going over here and say, is 1 divisible by 3? Is 3 divisible by 3? Is 5 divisible by 3? 7 divisible by 3? 9 divisible by 3? So assuming I run this, I'm generating a new list now. What elements should I have in here? 3 and 9. Nice. All right, so I believe we have this one passing now. And then we'll just go over this one quickly because this is one of those things that's interesting in Scala. So you'll notice here that we're actually defining a variable v and kind of passing that into this little function here. Scala actually has a nice shorthand syntax which allows us to kind of reference this variable here by a common name. So that's actually the underscore operator. So basically what I'm saying here is this is actually equivalent to this up here, except I haven't defined a variable v, and I could just save myself some typing. So basically this is just referring to v here. So I'm multiplying everything in here by 2, so what should I expect here? 2, 4, 6, right. All right, so this is the same syntax here. So except I'm doing modulus 2 double equals 0. So what should this expression evaluate to? 2. Only everything that's even in the list. Awesome. All right, so we're right at 2 o'clock, so I think it's time to wrap up. So hopefully this was a good introduction to some of the basic features of Scala. Does anyone have any questions before we kind of wrap up here?
Can you write on the board your GitHub where we can download this?
Yep. Yeah, I'll write it on the board, and I'll add some more instructions to the GitHub so you guys can actually run it locally within your IntelliJ.
Great, thank you.
Any other questions? Thank you.